In this video, we will be learning about sets with ellipses. So let's say we have a set where we count from 1 to 100, and we want to represent this in roster method. So we're going to have 1, 2, 3, and then we have to count all the way to 100. Is there a way we can minimize the amount of work we can do to represent this set in roster method? Well, it turns out there is a way. We have something in sets called an ellipsis, which is these three dots. You've probably seen this before. This means that it follows a pattern until it reaches a certain value. So for example, this set that we're trying to do here, where we're trying to go all the way to 100, we can put these three dots, or the ellipsis, and say it's from 1 to 2 to 3, and it goes so on, and we can put another comma after the ellipsis and put our number it reaches. In this case, it would be 100. So this would be a way we can utilize an ellipsis to represent a set that would take us forever to write down and represent in roster method. Now, instead of using the set to go from 1 to 100, let's see how we would represent the set from 1 to infinity. So infinity being forever. If we want to represent this set using an ellipsis going from 1 to infinity, all we have to do is, let's say we are at this point. All we have to do is just close the set. Since it's not going to approach a value that's a number, we can just have the ellipsis be the last part of the set, meaning it goes on forever until infinity. So here we have 1, 2, 3, and then that pattern repeats forever, essentially, or infinite times. So that's a way you can use an ellipsis to represent an infinite set. Now, we can only use an ellipsis whenever we can clearly distinguish a pattern in our set. So here we know that all we're doing is adding by 1 each time we have an element in the set, or we're just going up a number. So that's why we can use an ellipsis. But if we have numbers like 1, -4, 37, that's not a clear pattern we can distinguish. So we cannot use an ellipsis in a set like this. So for this first lecture problem, it says write the set of odd natural numbers including and between 1 and 99 and label it with a capital O, include an ellipsis when needed. So here we have our set name, which is going to be O, and we're going to open our set using curly braces. So here we want to include odd natural numbers including and between 1 and 99. So we're going to include 1 and 99 in our set. Now we just have to determine if the numbers from 1 to 99 are odd. So here we know that odd is going to be numbers that we cannot divide by 2 and get a whole number back. So for example, if we divide 1 by 2, we're going to get 1/2 or 0.5, which is not going to give us a whole number. So we can include 1 in our set. The same goes with 3. We can include 3 in our set. And then we also can include 5. So we can distinguish a pattern here. Essentially, we're just adding by 2. So now we can use our ellipsis to shorten down the amount of work we have to do for the set, because essentially we want to reach all the way to 99, because 99 is the last number in our set. So we can put an ellipsis here and say we count from 1, 3, 5, and so on, and we put a comma all the way until 99, and then we close our set. So this is going to be your answer. So for the second lecture problem, it says write the set of multiples of 5 that are greater than or equal to 5 and less than or equal to 50, and label it with a capital M. Include an ellipsis when needed. So M is going to be our set name here. So we're going to say M is equal to and open our set. So our elements in our set are going to be multiples of 5 that are greater than or equal to 5 and less than or equal to 50. So our range is going to be 5 to 50, because we have an equal two parts. So we can equal 5 in our set and we can equal 50. So that means we're going to start at 5. So multiples of 50 are just numbers that are factors of 5. So 5, 10, 15, 20, 25, and so on. So we can do 5, 10, 15, and here we can distinguish a pattern. We're just adding by 5 each time. So knowing that there's a pattern, we can use our ellipsis now. So we can put our ellipsis right there, and then we can put our final number that we're going to reach. In this case, it's going to be 50. That's the last element in our set. So we're going to put 50 there, and then we're going to close our set. So that's going to be your answer. So for this third lecture problem, it says, write the set of positive odd integers and label it with a capital I, include an ellipsis when needed. So our set name is going to be I, and we're going to open up our set. In this case, our elements are going to be positive odd integers. So integers are going to be whole numbers. So it can be numbers like -1, 200, 6 million, and so on. So integers can go on forever. It can go to negative infinity and positive infinity. But in this case, we're looking at positive odd integers. So our numbers have to be positive and odd. So we can start off and say 1. 1 is positive and 1 is odd as well. The same goes for 3. And the same goes for 5. So these three numbers are positive odd integers. And we can distinguish a pattern here. We're just going to add by 2 each time. So we can use an ellipsis here and say that this set is going to go on to infinity because integers can go on to infinity. So all we'll have to do is just close this set here, and that's going to be your answer. So for this fourth lecture problem, it says write the set of positive even numbers and label it with a capital E, include an ellipsis when needed. So our set name is going to be E, and we're going to open up our set. Our elements are going to be positive even numbers, so numbers like 2, 4, and 6. Remember, we're not going to include 0 because 0 is neutral. So 2, 4, and 6, and positive even numbers are going to go on all the way to infinity. 8, 10, 100 million, 1 billion, and so on. So it is going to reach infinity. So we can use our ellipsis here and say that this goes all the way until infinity because we clearly distinguish a pattern here. So we're going to close our set, and this is going to be your answer. Hey everyone, before we get back to the video, I just want to give a reminder to like the video if you enjoyed it, leave a comment down below if you have anything to say about the video, hit the subscribe button to stay up to date with some of the content I post, and to turn on post notifications to be notified when I upload. Thank you.